So question number 21 now. We have integral of tan square of 2x minus 3. Now as we know, this is linear function. So this you can imagine like x. And you also know that integral of tan square x, if you have, you need to convert the tan square x into what? Sec square x minus 1. Using which identity? Because of this identity, 1 plus tan square x equals to sec square x. You know this. We use this identity. Whenever we have tan square, we write sec square minus 1. So I'm using this identity here. So this is equals to sec square 2x minus 3. This is your angle theta. Minus 1 on the other side. Minus 1 the whole dx. Integral of tan square, which is sec square minus 1. Now what is integral of sec square? That is, you know, tan x. So tan of 2x minus 3 upon the coefficient of x, which is 2, minus integral of 1, which is x plus c. So this is required integral here. Second question, same. Question number 22 here, that is sec square 7 minus 4x. It's like previous question only. This is linear function. You can imagine this is x. What's integral of sec square? You know it is tan. Tan of 7 minus 4x upon the coefficient of x, which is minus 4 plus c. So minus 1 upon 4, tan of 7 minus 4x plus c. This is your answer. Okay. Next question, 23. Question number 23 here. Integral of sine inverse x upon root of 1 minus x squared. You must have realized by writing the question itself that 1 upon root of 1 minus x squared is derivative of this. So you can take sine inverse x equals to t. What's the derivative of sine inverse x? 1 upon root of 1 minus x squared, the whole dx equals to dt. Now you know such things, I'm not repeating. What I did, just placing sine inverse x equals to t, substitution method if you remember. What's the derivative of sine inverse x? 1 upon root of 1 minus x squared equals to dt by dx. dx I wrote directly on the left hand side. So this much becomes dt. So this is equals to here t dt. What's the integral of t? That is t squared by 2 plus c. Now in turn what is t? That is sine inverse x. So sine inverse x the whole square by 2 plus c. The same question you could have done like this also. See here, alternatively. Just I'm showing you whichever way you like. You can do like this. I can rewrite sine inverse x into 1 upon root of 1 minus x squared, the whole dx. This is f, this is f dash. If you remember, so here power is 1, here your derivative. So if you remember the formula, raise the power by 1. So sine inverse x the whole square by 2 plus c. This is direct answer. Which formula we use? Just recall this one. Integral of f raised to n into f dash is f raised to n plus 1 upon n plus 1 plus c. If you remember this formula, we use this formula here. Okay. Fine. Next question number, here let's go to question number 24. Question number 24. Integral of twice cos x minus 3 sine x upon 6 cos x plus 4 sine x. So you can see here that if you see the derivative of this precisely, what's the derivative of cos? minus sine, it is here. Forget about constant. What's the derivative of cos? Sine, which is cos. So if I multiply and divide by 2, for example, then you will realize, so this is 4 cosine x minus 6 sine x. Why I did, you will see, just wait for a moment. You will notice it is one of the standard formula. Now you imagine this is like f, then this become f dash, you can see. What's the derivative of denominator function? What's the derivative of 6 cos x minus 6 sine x? What's the derivative of 4 sine x, 4 cos x? F dash upon f. So what's your answer? 1 upon 2 log of mode of denominator function 6 cos x plus 4 sine x plus c. So you notice you must have, if you have nearby derivatives either in the numerator or denominator or in product, you can use this. How do we do alternatively? The another way of doing the same question is you take this much equals to t, put this equals to t. Right? The denominator expression equals to, you take t and you just continue, you get the same answer. I have used results here, not substitution, but you can do by substitution also. Next question, 25. Integral of 1 upon cos square x into 1 minus 10x the whole square. Okay. Now here the obvious observation is you can write 1 about cos x squared. Why we are doing this? Because you know derivative of 10 is x squared. So you have this much. Okay, now the obvious method is put 10x equals to t, remember. You can put entire 1 minus 10x equals to t also, doesn't make a difference. Why I did this? I can take these also, 1 minus 10x equals to t. Why I did this? Because you differentiate these, you will get this much. Now differentiation. Your 1, 0 minus sec square x equals to dt by dx. Dx I'll write on the left hand side. Now this minus will go this side here. So it will be minus dt. So I'll write minus here. This is dt. This become t square here because this was your t. This become dt. So 1 upon t square. Now how do we integrate this? You know, this is t raised to minus 2. So raise the power by 1. So t raised to minus 2 plus 1 upon minus 2 plus 1 plus c. So here this is minus 1, this plus 1. So this is 1 upon t plus c. This is minus minus plus. But what is t? That is nothing but 1 minus 10x plus c. So this way you can do. Or you could have done this way also. See, alternatively, if I do this, you can do this way also. Just I'm showing for your information. If you feel that substitution easy, you can do this way. 1 upon cos square is x square into, take this into numerator. So 1 minus 10x the whole raised to minus 2 dx. Right? Taking this expression into numerator. So now you just observe this is fx here, and if I multiply with minus twice, this become f dash. What's the derivative of 1 minus 10x? 1 0 minus I know that is 10x squared. So multiplying minus twice. So this much only, not power. This is f, this is f dash. So according to that formula, raise the power by 1. So 1 minus 10x raised to minus 2 plus 1 upon minus 2 plus 1 plus c. So therefore you will get the minus, this will come down here, 1 minus 10x. Here, this is here one more minus sign is already there. This minus sign is there here. So this minus and this minus gives us plus. So finally you are getting 1 upon 1 minus tan x plus c. This is your answer. The another way of doing the same question without substitution. If you feel that substitution easier, you can use it. Both are same indirectly, remember. Okay. Next question, question number 26. You can just see that here. The obvious way to do this is what? Substitution, because this is not linear function. Now there is a problem with which one? Root. So we put root x equals to t. And continue, you can do it. We'll go to next question, 27. So question number 27 here. Integral of root of sine 2x into cosine 2x dx. So how do we do this? Again, same method. You take this equals to t. Why we take this equals to t? Because derivative of sine is cos. So this become more or less dt. So put sine 2x equals to t. Substitution method, remember. What's the derivative of sine? You know, cosine 2x by chain rule into 2 equals to dt by dx. So we have this. Now cos 2x dx, you are already having this much. So I'll take 2 on the other side. So I'll get here half will go that side. This is root t and this become dt. It is actually half dt, but half already taken outside. Now we integrate this. This is t raised to 1 by 2. So raise the power by 1 divided by the same number. So which you can do very easily. Question number 28. Integral of cos x upon root of 1 plus sine x. So how do we do this? Same method. Put 1 plus sine x equals to t. Substitution method. If I put 1 plus sine x equals to t here, why this? That should be there in your mind, because derivative of sine is cos. So this become dt more or less. Derivative of 1 is 0. Derivative of sine x is cos x. dx equals to dt. Okay, so now if I come back to integral here, the whole numerator becomes dt here. 1 upon, what is this? This is root t. So if I take into the numerator, this is t raised to minus 1 by 2. Now you can integrate, raise the power by 1. T raised to minus 1 by 2 plus 1, which is 1 by 2 upon 1 by 2. Minus 1 by 2 plus 1. This is just 1 by 2. So you have 2 root t. But what is t? That is 1 plus sine x. So this is the answer. Plus c. Without these also you can do. Just I'm showing you. You can do like this. Or alternatively, I'll keep cos x as it is here. And 1 plus sine x I'll take in the numerator. So minus 1 by 2 dx. What I have in my mind is this, remember. I know that the derivative of this is already present here, f dash. So which formula? Raise the power by 1. So 1 plus sine x, increase the power by 1. Minus 1 by 2 plus 1, which is 1 by 2 upon 1 by 2 plus c. So this is equals to twice root 1 plus sine x plus c. This is your answer. You have used which formula here? Integral of f raised to n into f dash. It is nothing but f raised to n plus 1 upon n plus 1. This formula you have used here, remember. Okay. Now next question here. It's more or less same question. If you go back to 29th, integral of cot x into log of sine x. If you notice carefully, you can differentiate this very easily. What's the derivative of this? By chain rule 1 upon sine, and derivative of sine, which is cos. So cos by sine, it is this. So this is f dash. Now what is power here? 1. So again using the same formula, this formula. What's answer to this? Raise the power by 1. So log of sine x the whole square by 2 plus c. Which formula I've used? The same formula, f raised to n into f dash. Increase the power by 1 divided by the same number. Okay. Or you can use this. This is always there. Put this equals to t. Log of sine x equals to t. And just continue, you will realize. I'm just showing. My choice is yours, remember. Whichever way you want to do, you can use it. Substitution method, if you feel that it's easy, you can use it, remember. Question number 30th here. If you just observe the question, very easily you can see that it can be integrated by putting cos x equals to t. You can just try. 31, same way, you can put again just cos x equals to t or 1 plus cos x equals to t. Choice is yours, remember. Constant doesn't play any role because you know derivative is 0. So both you can try. I'll go to 32, question number 32. There you have 1 upon 1 plus cot x dx. So what we do is we reduce into sine cos here. So you have here cos by sine. So sine x plus cos x, cos by sine, and sine will go to numerator, sine x dx, remember. Now here in such questions, as I told you, this is like function upon function form. So we don't have division rule. So what I'll do, I'll set this expression over there. So sine x plus cos x. I'm just setting denominator expression into numerator. Now if I add plus x, I need to write minus cos x. Upon this much as it is. I repeat what I did here. What I did, first I set this denominator expression into numerator. So plus cos. Now when I do plus cos, I need to do minus cos. Now when you do individual division, when I write this upon this, here you will get 1. But what about this? This is again single term. So what I'll do, I need sine here. So I'll write one more sine. So cos will get cancelled. How many times you wrote sine? That is 2 times. So I need to write 1 upon 2 in front of this. Now you can see that the both are same. If you want, you can do intermediate step like this here. I can write 1 by 2 into twice sine x upon this is sine x plus cos x the whole dx. Now here you can see that twice sine x, you can write sine x plus sine x, and adding cos, subtracting cos. Now you do individual division. This is a standard integral. You will see here, you will get in, when I do individual division, you will get here this upon this, that is just 1, this upon this 1, minus, I'll take common. So you have cos x minus sine x upon sine x plus cos x. Now you can see over here, integral of 1 is known to you. What's integral of 1? That is nothing but the x. What about this? If you notice here, what's the integral of what's the derivative of this portion? What's the derivative of sine? It is cos. And what's the derivative of cos? It is minus sine. So this look like f and this look like f dash. So you have here finally 1 upon 2 integral of 1, that is x, minus this is f dash upon f. So log of mode of denominator expression. This is your answer, plus c. How will do this? Alternatively, you can take this equals to t, so this become dt. What I did here, let me repeat. Here at this place, you can see that derivative of sine, it is cos, derivative of cos is minus sine, so it's f dash upon f. So you are getting log of mode of denominator function. So this is your answer. Okay. Now same way you can try this question also. It's just same as this, integral of 1 upon 1 plus 10x. Try this. It's just a copy of above question. What you did basically here, you have expressed this function in this form. If you have upon f, then this you have expressed function plus its derivative. That concept you have used. You can see your f upon f gives us 1 and f dash upon f. That you did basically in this question. Okay, now next question number 33. So it's like previous only, as I mentioned here, 1 upon 1 minus 10x dx. So same question, like this or like this. You reduce into sine cos and then you express numerator in function plus or minus f dash upon f form. It can be minus also, remember here also. Try it. This is for you. Try yourselves. It's just copy of 32. Question number 34 here. You have root of 10x upon sine x into cos x. So if you have root expression, we put that expression equals to t or t squared. So I'm taking this equals to t here. Now after taking substitution, we differentiate it. So we'll get the here sec square x dx equals to dt. Now you don't have sec square here, you just get dx from this. So what's dx from this? 1 upon sec square, which is cos square x dt. So you have this equals to here root, this is t upon, now sine x cos x, let me keep right now as it is. This is cos square x dt. So 1 cosine will get cancelled from this here. So this is sine by cos. So root t upon, this is 10x dt. But what is 10x? It is t. So you will get the root t upon t dt. So it is just t raised to minus 1 by 2. And now we integrate it. So raise the power by 1. Minus 1 by 2 plus 1. 1 by 2 upon 1 by 2 plus c. So this is equals to 2 times, this is root t, but t is 10x plus c. This is your answer. Okay. Now next question. 36. So let's do that. Question number 36 here. Integral of x plus 1 into 1 plus log x the whole square by x dx. This is the question. So here substitution would be, you can see that just log x will not do. You need to take entire x plus log x equals to t. This is your substitution. Why? Because you see here derivative of x will be 1, derivative of log x is 1 upon x, which will get from simplification. So here 1 plus 1 upon x the whole dx equals to dt. Differentiation here, remember. Now what is this? This is x plus 1 upon x into dx equals to dt. So you can see that this become dt. This much is dt. So the above question reduced to now, this is equals to, this is just dt, and here you have t squared. This was your t, so t squared. And now this is t cube by 3 plus c. But what is t? That is x plus log x the whole cube upon 3 plus c. This is your answer. Just resubstituting the value of t here. Next question, 37 number. X cube into sine of tan inverse x by 4, x raised to 4 upon 1 plus x raised to 8 the whole dx. Now clearly, if you notice carefully, the derivative of this one is already present here. So I'll put that bracket equals to t at this place. This much equals to t. So tan inverse here, tan inverse x raised to 4 equals to t. Differentiation by chain rule. 1 upon 1 plus x squared. So x raised to 4 the whole square. By chain rule, this is 4x cube into dx equals to dt. By chain rule differentiation. Now everything is present, just 4 is not there. So I'll take 4 on the other side, this 4. 1 plus x raised to 8 dx equals to 1 upon 4 dt. Okay, so now the above integral reduced to 1 upon 4, I'll keep outside here. X cube 1 plus x raised to 8 and dx. You can see that it is just 1 by 4 dt. So this is dt. This will goes away with dx with x cube. This much is t. So we are just left with sine t, which is very standard function. What is the integral of sine? You know it is minus cos. So here you have minus cos t plus c. But what is t? So minus 1 by 4 cosine t is tan inverse of x raised to 4 plus c. This is your answer. Now 38 number MCQ. You can just try. I think you can just notice it would be probably f dash upon f form if you verify. So it would be log of mod of f plus c. Just try this. Or put denominator equals to t. Question number 39, if I see here, 39 number, this place. Integral of, you have 1 upon sine square plus into cos square the whole dx. Now here you have product. So later on you will learn there are various ways, but right now the easiest way is, instead of 1 you can write sine square plus cos square upon sine square x into cos square x the whole dx. What I did, just in place of 1 I wrote sine square plus cos square. Now your two terms, your single term, so individual division. This upon this, sine square will get cancelled, 1 upon cos square. Plus, there, cos square will get cancelled. So we'll get the 1 upon sine square, the whole dx. So this is equals to, what is 1 upon cos square, which is x square. What is 1 upon sine square, which is cos x square. Now both are standard functions. You can integrate very easily. What's the derivative integral of x square? Tan x. What is the integral of cos x square? Minus cot x plus c. This is your answer. So tan x minus cot x plus c. So the correct option is, I suppose, B. That's your answer. Integral of x square tan, integral of cos x square minus cot plus c.